Hello everyone, welcome to my math channel. This is Mr. Mahmoud explaining Algebra 2, Chapter 6, Lesson number 10, using logarithms in solving exponential equations. Let's start by the rule of this lesson that f of x equals a e to the power of kt while the situation represents exponential growth, and f of x equals a e to the power of negative kt while the situation represents exponential decay. What is a? A is the initial value, t is the time in years, or as it's given in the problem. K is a constant representing the rate of continuous growth in this case and continuous decay in the second case. Sometimes we can write this rule as y equals a e to the power of kt in the case of growth, and y equals a e to the power of negative kt in the case of decay. And also we can use a equals p times e to the power of rt in the case of your principal is compounded continuously, such that P is the principal amount of money you deposit into a bank account, and R is the rate that you and the bank agreed for, and A is your final balance, and T is the number of years. Example: the half-life of sodium 22 is 2.6 years. Determine the value of K and the equation of decay of sodium 22. The half-life is the time taken for a substance to be half of its original. So, if A is the initial amount of the substance, then the amount y that remains after 2.6 years is half of A, means half of the original amount, or 0.5A. This is the original formula, y equals A times e to the power of negative kt, because this is decay situation. So we replace the y with 0.5A equals A times e to the power of negative k times 2.6. And we will divide both sides by a, so a got cancelled. So 0.5 equals e to the negative 2.6k. Now we can take ln for both sides, because we know that ln and e are inverse functions, so they vanish each other. So that ln 0.5 will be negative 2.6k. Now we can divide by negative 2.6 for two sides. So the k equals ln 0.5 over negative 2.6, and this will give you k as an answer 0.2666 or 0.2666. So the value of k of sodium 22 is 0.2666. Thus the equation for the decay of sodium 22 is y equals a e to the negative 0.2666t, where t is given in years. Now this is your turn to solve. Pause the video and try to choose whether it's A, B, C or D, and you will find it C. Let me show you how. The half-life of radioactive iodine used in medical studies is 8 hours. Means after 8 hours it reaches its half original amount. What is the value of K for radioactive iodine? So we will start with the rule y equals a e to the negative kt, because this is decay situation. And we know that half-life means A will be half of A. or 0.5a. So I can replace y with half a equals a e to the negative k and time after 8 hours, so it's in hours, no worries. So now let's divide by a for both sides, and we can write the half as 0.5 equals e to the negative 8k. Now we can take ln for both sides, so ln 0.5 for the left hand side and ln e to the negative 8k for the right hand side. Now we all know that ln and e will vanish each other because they are inverse functions, so ln 0.5 will be negative 8k. Now we can divide by negative 8 for both sides, so k equals ln 0.5 over negative 8, and it will be approximately 0.0866. So really C is the accurate choice. A geologist examining a meteorite estimates that it contains only about 10% as much sodium-22 as it would have contained when it reached Earth's surface. How long ago did the meteorite reach the surface of the Earth? How long ago means we need time. Let's understand the situation. The formula for the decay of sodium-22 is y equals a e to the negative kt. It's decay, so k in negative. You want to find how long ago the meteorite reached Earth. Means you need to find the t. So let a be the initial amount of sodium-22 in the meteorite. The amount y that remains after t years is 10% of a, means 0.10a, or you can say 0.1, the same. Let's solve. So we begin with the rule y equals a e to the negative 0.2666t, and we replace the a with 0.1a, which is the same as 0.10, equals a e to the negative 0.2666t. Now we divide both sides by a, so a got cancelled. So 0.1 equals e to the negative 0.2666t. So now we take ln for both sides, so that ln will cancel the e. So ln 0.1 equals negative 0.2666t. Now you can divide both sides by this number to get t alone. So t is about 8.64 years. So it reached the surface of Earth about 8.6 years ago. You can check your answer. Use the formula to find the amount of the sample remaining after 8.6 years. Use the original amount of 1. So y equals a equals e to the negative 0.2666t, and now we can replace the t with 8.6, and let's see what will be the result. So we replace the a with 1. We replace the a with 1, and the fraction will appear here, will be the accurate answer. So it's really about 0.101 or 10%. Now this is your turn to solve. Pause the video and try to choose, and you will find the accurate answer will be D. Let me show you how. The half-life of radioactive iodine used in medical studies is 8 hours. A doctor wants to know when the amount of radioactive iodine in a patient's body is 20% of the original amount. 20% means the amount of A will be 0.20 A, or you can say 0.2. So we need to know the amount of radioactive iodine in patient's body. It will be 20% of the original amount. When will this occur? When means we are asking for the t. So let's begin with the rule y equals a e to the negative kt, because we know that it's decay situation, and we can replace the y with 0.2a. It's the same as 0.20, by the way, equals a e to the negative k, which is mentioned before as 0.0866t. So now we can divide both sides by a, so a got cancelled. So 0.2 equals e to the negative 0.0866t. Now take ln for both sides. So ln 0.2 equals ln e to the negative 0.0866t. Now we all know that ln will cancel the e, so ln 0.2 equals negative 0.0866t. Now we divide both sides by this number, so we can get the t equals ln 0.2 over negative 0.0866, and this will give you about 18.58 hours. So really D is the accurate choice. Now another example. In 2007 the population of China was 1.32 billion. In 2000 it was 1.26 billion. Determine the value of K, China's relative rate of growth. So we begin with the formula y equals a e to the power of kt, because it's growth. And we can substitute now that the population of China 1.32 billion. In 2000 it was 1.26 billion, means this is a new one, 1.32, so we'll put it here in the place of y, and 1.26 here in the place of a. And the time is taken from 2000 to 2007 is 7 years, as you can see. So just divide both sides by 1.26 to give you 1.32 over 1.26 equals e to the power of 7k. And also we can take ln for both sides, so that ln will vanish the e. So it becomes ln 1.32 over 1.26 equals 7k. Now let's divide by 7 for both sides, so that you can know the k equals 0.0066. So China's relative rate of growth is about 0.0066, or about 0.66%. To get the percent, you just move the decimal point to the right 2 places. In 2007 the population of China was 1.32 billion. In 2000 it was 1.26 billion. When will China's population reach 1.5 billion? When we need the t, we need the time. So we are going to use the rule with the same k we had in part A of the example. Y equals a e power kt. So we know that we want to reach 1.5, and the original amount, it was 1.26 in the year of 2000, and we know that this was the k we had in part A from the example. So we substitute. We can divide now by 1.26 for both sides. So 1.5 divided 1.26 will give you 1.1905 e to the power of 0.0066t. Now take ln for both sides. Ln will cancel the e, so that we can have ln 1.1905 is approximately equal 0.0066t. So we can divide by this number to know the value of t, and t will be approximately 26.4202. Means China's population will reach 1.5 billion after 26 years, starting 2000, so it's 2026. In 2007, the population of China was 1.32 billion. India's population in 2007 also, it was 1.13 billion, and can be modeled by y equals 1.13 e to the 0.015 t. Determine when, we need the time, determine when India's population will surpass China's population. Means surpass means will be larger, means will be greater than. So this is what we want, that India will surpass China, means India will be bigger, so the inequality sign is facing India now. This was the beginning of China at 2007, 1.32 e to the, this was the rate of growth of China's population, 0.006646 t, and when it will be smaller than 1.13, the beginning in 2007 for India, e to the power of 0.015 t, this was the rate of India as given in the problem. Now if we can solve this inequality, we can know the value of t. This is very easy. Just take ln for both sides, and you know that ln will break the multiplication into addition using the very famous rule ln xy equals ln x plus ln y. So this will be ln 1.32 plus ln e to the power of 0.006646 t smaller than ln 1.13 plus ln e to the 0.015 t. Now we can get the terms with t together and the terms without t together, but before we know that ln will cancel the e and ln will cancel the e, so it takes this shape. So now let's move the terms with t together and the terms with ln together. So ln 1.32 minus ln 1.13 will be smaller than, of course we are going to subtract 0.015 minus 0.006646, and it will give you this number 0.008354. You can try it using your calculator. Now we should divide both sides by this number to know that t should be bigger than ln 1.32 minus ln 1.13 over 0.008354. Now we should know that t is greater than 18.6, means India's population will surpass China in about 18.6 years, or the midway through 2025, because we have started our study at 2007. So if you add about 18.6 years, this will give you 2025.6 years, means midway through 2025. Now this is your turn to solve. Pause the video and try to choose, and you will find the accurate answer will be B. Let me show you how. In 2006, the population of Alaska was 670,000. In 2000, means at the beginning it was 620,000. Determine the value of K, Alaska's relative rate of growth. So we start by y equals a e to the k t, and we put here the new amount in 2006, which is 670,000 equals a. The original amount in 2000, it was 620,000 e to the power of kt. We don't know the k, but we know that the t from 2000 to 2006 means 6 years. So we can now cancel 4 zeros with 4 zeros, and then we divide by 62 for both sides. So here 67 over 62 equals e to the power of 6k. Now we take ln for both sides, so ln 67 over 62 equals, the ln will cancel the e, equals 6k. So divide by 6 for both sides, k equals ln 67 over 62 all over 6, and you will find it approximately equal 0.01293. So B is an accurate choice. Now in 2006, the population of Alaska was 670,000. In 2000 it was 620,000. When did Alaska's population reach 700,000? Means this is our aim. We need to reach for this one, and we need to know when. We need to know the time. So also we begin with the same y equals a e to the power of kt, and y, this is our aim. The new population is 700,000 equals a is the beginning in 2000. It's better to take 2000 so that we can know in which year directly. So it was 620,000 e to the power of kt. T is the unknown, k is known from part A of this problem. It was 0.01293 t. So now we can cancel also 4 zeros with 4 zeros, as if we are dividing by 10,000, and then we divide by 62 for both sides. So you have here 70 over 62 equals e to the 0.01293 t, so that you can take ln for both sides. So this will be ln, this fraction can be simplified into 35 over 31, or you can leave it the same, and ln will cancel the e, so 0.01293 t. Now we can divide both sides by this number, so t equals ln 35 over 31 over 0.01293, and you will find it approximately 9 years. So 9 years starting 2000, it will be really in 2009. By this, my dear students, we come to the end of our lesson for today. Till we meet again, goodbye.